Okay, so guys, today we're going to talk about the graphical method of adding vector quantities. But first, we have to know the basic thing in adding these vectors. So let's start with giving an example on how to name a specific vector. So let's say, for example, we have an example here. So we have 30 meters, 30 degrees north of east. So this one is an example of a vector quantity. And then let's try to graph that using the Cartesian plane. So imagine this is our Cartesian plane. So this is the origin, this is the quadrant 1, 2, 3, and 4. And then we are going to plot or graph our given. So we have 30 meters, 30 degrees north of east. First, you have to identify the direction of our vector. So that's north of east. So it means it's from east going to the north. So from here going to the north. Okay. So the direction of our vector is like this. From its x-axis going to the y-axis. So we have 30 meters. The magnitude is 30 meters. So let's say, for example, for every 10 meters, that's 1 inch of your ruler. So this is the first inch, which is 10 meters, then another inch, which is another 10 meters, then the last inch for this vector, which gives you 30 meters in total. So since it's a vector quantity, you have to indicate that it's an arrow. Okay, and then so since it's north of east, the angle will be placed here. That's 30 degrees, no? So that's 30 meters, and this is 30 degrees. Therefore, the graph of your vector is like this. That's 30 meters, 30 degrees north of east. Now, there are different ways on how to name this, of course. You can name that as our given, so 30 meters, 30 degrees north of east. But you can also name that as, let's say, 60 meters, 30 meters, 60 degrees east of north. Okay, so it means since you have 30 degrees here, for this quadrant from here to here, that's 60 degrees, right? Okay, so you can also say it's 30 meters, 60 degrees east of north. Okay, so we are down with our number 2 example. So we have a vector with 5 meters, 80 degrees south of west. So the first step before graphing your answer is, of course, getting the or identifying the direction. So we have here the direction south of west. Okay, so south of west, it's basically on quadrant 3. Okay, so the south of west is from west going to the south. So from here going to the south. So this is the direction of your quantity, from west going to the south. Now we have 5 meters. Let's say, for example, 1 inch of your ruler is equal to 1 meter. So you will have to measure 5 inches using your ruler. So let's say, for example, this is already 5 inches. Then since it's vector, you have to put the arrowhead. And then this is 5 meters. And the angle will be 80 degrees. Now, so that's your graph for this vector. But what are the two names? What are the two possible names for this vector? So we have, of course, our given. We can also say it's 5 meters, 80 degrees south of west. But we can also say it's 5 meters, 10 degrees west of south, or from south going to the west, that's 10 degrees. Okay, so for our number 3 example, we have here 6 meters 25 degrees south of east. So let's try to graph that. Let's start with identifying our direction, that's south of east. And south of east is basically found on the fourth quadrant. Okay, so here, so the direction will be from east going to the south. So from here going to the south. Now we have here 6 meters. So using your ruler, you can use 1 inch as 1 meter. So you will have 6 inches for this vector. So imagine that's already 6 meters for 6 inches. Then you can place, or you can write 6 meters here, and then you can write or place the angle here. It's 25 degrees. Therefore, this is the graph of 6 meters 25 degrees south of east. How to name that? Let's write its possible names. So we have, it can be called as 6 meters 25 degrees south of east, but it can also be called as 6 meters and 65 degrees east of south.